Let's measure the density of the green bottle and the red bottle now. To measure the density, we need to work out the mass and also the volume of these two bottles. So using Archimedes' method, we can work out the volume of water displaced by the bottle when we submerge it. So at the moment, this beaker is saying that there are 3,000 millilitres of water in here. Let's now submerge this red bottle. It's now saying that there are 3,600 millilitres of water in the beaker. So this bottle has a volume of 600 millilitres. Now to get its density, we also need to measure its mass. So let's take the handle off and we can weigh it. It has a mass of 1.2 kilograms. So to get the density, we do the mass, the 1.2, divided by the volume, which was 600 millilitres. And so this tells us that the density is equal to, we get 2 kilograms per litre. So that's quite a lot more dense than water. Let's now check this much lighter green bottle. When we put this one into the water, the volume is displaced up to 3,600 millilitres. So this has a volume of 600 millilitres. Let's now check its mass. The mass of this one is 30 grams. So 30 grams divided by 600 millilitres. So 30 grams divided by 0.6 litres gives us 50 grams per litre or 0.05 kilograms per litre. So this one is much less dense than this one. Now one other interesting thing to note is that when we submerge this, the volume increases by 600 millilitres, but the mass on the scale also goes up by 600 grams. Now this is actually because of a reaction force. This water is providing a buoyancy force to the bottle. So the buoyancy force provided on the bottle is the weight of the bottle times the volume. So the buoyancy force it provides to the bottle is equal to rho Vg, and so that's proportional to the volume. Now to get that buoyancy force, there's an associated force of the bottle pushing downwards on the scale. And so the scale actually reads an extra 600 grams, which is equal to the mass of that water which is displaced by the bottle. With the red bottle, we get the same reading on the scales. It's also changed by approximately 600 grams because we've got the same mass of water displaced. It doesn't matter about the different densities. If I let go of this handle, the reading goes up a lot because we've added the extra weight force from the red bottle. Archimedes' principle is that the upwards buoyancy force on an object is equal to the weight of the fluid that the object displaces. So have you ever wondered why when you get into a swimming pool it feels like you are floating, and then if you get into seawater it feels like you're floating even more? Well, this is because your body has volume. When you get into the water, you're displacing a certain volume of water. And so there's a buoyancy force on your body. And that buoyancy force is equal to the weight of the water that your body displaces. Now you may have heard about the Dead Sea, which is near Jordan. The Dead Sea has an especially high density. If you have a metre cubed of water from the Dead Sea, that's got a density of 1,240, well, that would have a mass of 1,240 kilograms. Whereas fresh water, if you have 1 metre cubed, weighs 1,000 kilograms. So in the Dead Sea, people float even more because the density of the Dead Sea is very close to the density of the human body, and so you float without even trying in the Dead Sea.